Hello and welcome back to Stadpro V8i Advanced Training Series. In this video, I'll explain how to perform static analysis as per IS1893 2002. To explain the analysis procedure, we will consider a 4-story reinforced concrete office building as shown in the figure. The building is located in Shillong, hence the seismic zone will be 5. The soil conditions are medium stiff and the entire building is supported on a raft foundation. The RC frames are infilled with brick masonry. The lumped weight due to dead load is 12 kN per meter square and 10 kN per meter square on roof. The floors carry a live load of 4 kN per meter square and 1.5 kN per meter square on roof. Let me label the dimension of the building for your reference. The span of the building is 5 meters in both X and Z direction. All the supports are assigned as fixed supports. The size of the beams are assumed to be 0.23 by 0.4 meters and that of the columns are 0.23 by 0.45 meters. The material is assumed to be concrete. This video, I'll explain how to define IS1893 seismic loading definition. Further, we will apply that defined load to the building and we'll analyze the building. To define the seismic definition, as explained in previous video, click on Commands, click on Loading, go to Definitions. Seismic load definition, select IS1893 2002. Let us use Generate Definition option. Since we know that our zone is 5, let us directly select the zone as 5. Since the building is provided with moment resisting frames detailed as per IS13920 1993, we will select Special RC moment resisting frame for response reduction option. The importance factor of the building will be 1 and the soil type will be medium soil. Type of structure will be RC frame building. Since our building is made of moment resisting frame with brick infill panels, we should use the empirical expression to calculate the fundamental natural period as 0.09 h divided by root of d. By default, Stadpro calculates the fundamental natural period of vibration by using the expression TA equals 0.075 h raised to 0.75 for RC frame buildings. So in this case, we will have to manually calculate the natural period of the building in X and Z direction. The lateral load resistance is provided by moment resisting frames infilled with brick masonry panels. Hence, approximate fundamental natural period in X direction will be T equals 0.09 h divided by root d. For our building, the total height of the building is 13.8 meters and the dimension of the building in X direction is 20 meters, which makes the natural period of building in X direction as 0.28. Similarly, we can calculate the natural period of the building in Z direction as 0.32 seconds. So we will manually input the value of period in X and Z direction as 0.28 and 0.32 respectively. Click on Generate button to generate the definition. Specify the damping ratio as 0 to obtain accurate results. Click on Add button to add the definition to the stat file. This definition will help Stadpro to obtain the value for AH in the equation of base shear, that is VB equals AH into W. Now we have to specify Stadpro how to calculate the seismic weight of the structure. To help Stadpro to calculate the seismic weight of the structure, we will define flow weights in the building. Since the building carries a lumped dead load of 12 kN per meter square on floors, let us input a pressure of 12 kN per meter square for a Y range of 0 to 11.5 meters, which will apply a flow load from this point to the third floor. Click on Add button, and the floor carries a lumped dead load of 10 kN per meter square. So the range will be 11.5 to 15 meters, which will apply a uniform load pressure of 10 kN per meter square on the roof. Click on Add to accept the definition. Again, the floors carry a live load of 4 kN per meter square. Since the value of live load is more than 4 kN per meter square, 50% of live load will be lumped on the floors. At roof, no live load is to be lumped, and hence 50% of 4 kN per meter square will be 2 kN per meter square with a range of 0 to 11.5 meters, which will apply a live load pressure of 2 kN per meter square on these 3 floors. Click on add to add the flow weights. This completes the seismic definition according to Indian Standard Code 1893/2002. After completing the load definition, we will have to apply the load on the building. Since we are having a seismic definition in our problem, the first load case that we have to define will be the seismic load case definition. If we define the dead load case or imposed load case before defining the seismic definition, it will show error during the analysis process. So first let us define the seismic load cases. To define a load case, click on the load case and click add button. This will be the seismic load definition case in positive X direction, and we'll select the load type as seismic. Selecting load type in Stadpro will help Stadpro while we define the auto load combinations, and the Stadpro will automatically generate load combinations as specified in the code. So we will define the load type as seismic and the load case 1 in positive X direction. Click add to add the selection. Now the load case 2 will be in positive Z direction. Again, the loading type will be seismic. Click add. Now let us apply the seismic load case in X direction. Select the seismic load case 1 and click add. Now select seismic load in X direction with a factor of 1. Click add. Similarly, we will define the load case in Z direction with a factor of 1. Now let us define the load cases for dead and imposed load. Load case 3 will be dead load case. Select loading type dead. Again, we will have a live load case of load case 4 and click add. In the dead load case, we will be having a flow load of intensity minus 12 kN per meter square for a Y range of 0 to 11 meters in global Y direction, and a load of intensity minus 10 kN per meter square for a Y range of 11.5 meters to 15 meters. This will be our roof load in global Y direction. Again, we have to apply a live load in the form of flow load of intensity 4 kN per meter square for a Y range of 0 to 11 meters in global Y direction, and a live load on the roof with an intensity of minus 1.5 kN per meter square for a Y range of 11.5 meters to 15 meters or 11 meters to 15 meters. The Stadpro will automatically identify the flow levels and apply the flow loads accordingly. Before moving to auto load combinations, we have to define the analysis and print data command between loading case 1 and 2 and loading case 2 and 3. This will help Stadpro to calculate loads for load cases 1 in X direction and load cases 2 in Z direction before doing the combinations. To add analyze command between load case 1 and load case 2, go to analysis and print option, select load case 2 and click on define command option. We will print the load data, check the after current option and click add. After performing an analysis, we will use the change command to reset the stiffness metrics. If you want to learn more about the change command, please watch the previous video. Now we will add change command after load case 2 and perform and print load data command. The perform analysis and load data command will help in Stadpro to perform the analysis for seismic load case 1 and save the result file to study the simultaneous effect in the load combinations. Now let us go back to the loading definitions and we will define the load combination. In the limit state design of reinforced and pre-stressed concrete structures, code suggests following load combinations, that is 1.5 dead load plus imposed load, 1.2 dead load plus imposed load plus or minus earthquake load, 1.5 dead load plus or minus earthquake load, 0.9 dead load plus or minus 1.5 earthquake load. So let us define these loads and load combinations to the stat file. To add the load combination, click on the load case details and select the add option. On the left side you can see the auto load combination option. We'll select the load combination code as Indian code. Select the load combination category as general structures and click on generate load command. Now Stadpro will automatically generate the load combination as per IS1893 code for the limit state of design of RC structures, with first load combination as 1.5 times live load plus 1.5 times dead load. Again 1.2 times dead load plus 1.2 times live load, with earthquake load combinations as 1.2 times dead load plus 1.2 times live load plus 1.2 times earthquake load in X direction. Again 1.2 times dead load plus live load plus earthquake load in Z direction. Similarly, earthquake loads in negative Z and negative X direction is defined in load combinations 5 and 6. We will select the repeat load cases option. This will create auto load combinations with repeat command, which will help Stadpro to analyze the building with simultaneous effects of our load cases. Click add to add the auto load combinations. Now to print the results, go to analysis and print option. We will add perform analysis command. After adding perform analysis command, we need to print the results for the load combinations. To select the load combinations required to print our results, we can go to post print tab and click on the define command option. We will add a command called load list option, and we will select the load cases ranging from 5 to 12. So from this point onwards, Stadpro will consider only these load cases to print the data. If you don't select the load list option, the Stadpro will print the data for all the load cases. So we are restricting the load cases required to 5 to 12, so that the Stadpro will now print the results for only these load cases. Click add to add the command. Again go to define command option and select the joint displacement option. To print the joint displacement, we have to add the support reaction command. Click add to add the support reaction command, and we will add the member forces command. We have to display the joint displacement for all the nodes in the structure and support reaction for all the supports. So we will select the joint displacement command and we will apply it to the view, which will apply the command to the whole structure. And again, the support reaction has to be applied to the whole structure. Suppose we want to print only the member forces for the bottom columns. Select the print member forces command and select the bottom columns and click on assign option to assign the print member forces command to the bottom columns. Now our structure is ready to be analyzed. We'll go to analysis command and run analysis. We'll check the output file, select the view output file option and press done. We have a warning. Again, as I explained in the previous video, this is a reminder since we have used the floor command. Since our structure is having a rectangular floor, this warning can be ignored. Again, moving down to the results, the Stadpro has used a time period of 0.28 second for load case in X direction, as we already specified in the Stadpro, and the Stadpro has calculated a SA by G factor of 2.5 and load factor of 1 for the calculation of base shear value VB as per IS1893. The factor AH for the equation has been calculated as 0.09, and the seismic weight of the building has been calculated as 15,600 kilonewtons. Stadpro has applied the load in positive x direction as nodal loads. These are the calculated nodal load values, and with a total value of 77 kilonewton in x direction at a level of 4.2 meters. Again, for the level of 7.4 meters, lateral load value is 39.669 kilonewtons. Again, the sum lateral loads 10.6 meters is 491 kilonewton. For the roof, the lateral load value has been calculated as 595 kilonewtons. Similarly, the time for z direction for 1893 loading, as we specified earlier in the definition, as 0.32 seconds has been used by Stadpro, and again SA by G value has been calculated as 2.5. There is no change in the value for AH, that is 0.09, with a seismic weight of 15,600 kilonewtons, which has been used to calculate the base shear value. Again, the loads has been applied as nodal loads in FZ direction up to a level of 13.8 meters, that is the roof level. Moving down to the STAT output, the joint displacement values for the load cases ranging from 5 to 12 has been printed for the joint ones. The translation XYZ direction and rotation XYZ direction has been printed by the Stadpro. Since we use the command load list option, the Stadpro has printed only the results for the load combinations 5 to 12 as specified in the load list command. The joint displacement for all the joints in the structure has been printed. Moving down, here we can see the support reaction values for joints 1, 4, 6, 8, 10, 11 for load cases ranging from 5 to 12. Stadpro has printed the force in X, Y and Z direction and moment in X, Y and Z direction. So these are the support reactions for the supports in our structure. The member end forces for the bottom columns has been printed for the load cases ranging from 5 to 12. These values can be used for the design of the bottom columns. Stadpro has printed the axial values and shear forces and torsion and moment values for the bottom columns for load cases 5 to 12 for joint 1 and 2 for each and every members. So this concludes this video. Thank you for watching the video. For more videos and updates, please subscribe to our channel Online Civil Digital. Your comments and queries are valuable to us. Please use the comment option to comment the video. In the next video, we will learn the modal calculation, the participation factors in the dynamic analysis of a structure.